For this homework, I implemented the significance weighting in the user KNN recommender library for LibRack. And the original file given to us, we had the setup method, train model, predict, and create user similarity list methods. And I add one more method, which is called getWeighted stands for similarity matrix. It's only being called in the setup function, so I did not edit the rest of the three methods that were given to us. In addition, I added the beta variable, which captures the overlaps coefficient, and it reads from the configuration file, which is here. So how my method works is that, first of all, it will find and store the rated items indices into hash sets for each user, and then it compares and find the intersection of the set of item indices among each pair of users, and then calculate how many what is the number of commonly rated movies between those two users. If that item is greater than 0, if that number is greater than 0, and also that number is less than the beta, which is the case when the similarity coefficient needs to be updated by the significance weighting, then we will go ahead and calculate the coefficient, which is the number of commonly rated movies between two users divided by the beta, which is the overlap coefficient we set. Then we're gonna take the original similarity times that coefficient to get an updated similarity. Then we're gonna overwrite that similarity value in the similarity matrix. I overwrite that because the similarity matrix is initiated in the setup method, which is then used in the create user similarity list, which is called in the predict method. So by updating the similarities in the setup function, we can make sure that the rest of this program will use the updated similarity. So here we're gonna first try to use the MAE evaluator, which stands for the mean absolute error, with nearest number of neighbors equals to 50, and the similarity the beta for the significance weighting equals to 5, and see and test run this function. So you see when beta equals to 5, the MAE is about 0.755. Then we can also evaluate it with the precision metric. In this case, we need to change the evaluation class to precision evaluator, and then change the is ranking, which is a Boolean variable, to true, and then set the top number of ranked neighbors to 10. So to calculate precision, it does take a little bit more time than calculating the mean absolute error. So let's give it a couple seconds. Alright, so we can see that it does take about half a minute to calculate the precision. And in this case, when beta equals to 5, the precision is around 1.56%. Because it takes much longer time to compute, I pre-calculated everything, and here is the values for precision before and after with different beta values, and also same for the mean absolute error. And we can see that for both MAE and precision, they don't really improve that much by implementing the significance weighting.